Good afternoon, guys. I just need some vocabulary. You got a little quiz tomorrow, so make sure you do it. We're going to be working on the Pythagorean theorem, but not the way that you guys are used to it. We're going to be working at a much deeper level. You're going to have a lot of background knowledge. So we're just going to do some vocab so that when we go to work on the problems, you know what the problems are asking you for. So just label it 9.4 Pythagorean theorem. I'll be teaching tomorrow, so just be prepared to add to what we're doing tomorrow. If you want to do this on some little index cards, that'd be great. All right, so here's the important vocab. Median. A median is a line segment that originates at a vertex and goes to the opposite side of a figure and cuts opposite side in half. So for example, if I have a triangle like so, if I start here at this vertex and I go to the opposite side, a median is going to cut these two in the same length, so we call that line a median. It's not the same as an altitude because altitudes make right angles, okay? Medians just cut the opposite side in half, okay? So that's a median. If you want to write that down, go ahead and stop me because I'm going to erase it. Now we're going to do diagonal. A diagonal is a line that connects a vertex to another vertex on a figure. So for example, let's just do a rectangle. If I'm going to do a diagonal, if I start here, I'm not going to draw a line to here. That's not a diagonal because it's already connected. So it would connect to a vertex that it's not connected to. Or if on a pentagon, say I have a pentagon, if I start here, I can't connect to this point, but I can connect there, or I can connect there, and we call these lines diagonals, okay? There's a bunch of them, but they're diagonals, okay? So again, if you didn't get that down, you can erase, you can pause and get it written down because I'm going to erase. All right, the next one is a slant height. A slant height is a height on a triangle or a trapezoid. It's not the real height, okay? So like for example, here's a trapezoid here. This would be your height. Remember, the height is always connects to the base from a vertex to the base with a right angle. That's a height. This guy right here is your slant height. Okay, so that's what you call a slant height. They're different measures, okay? All right, now the next one is equilateral. Equa meaning equal, and the word lateral meaning sides. That's what laterals mean. So figures that are equilateral would be a square, an equilateral triangle where all the sides would be the same and all the angles would be 60, 60, 60. So equilateral is just all the sides would be the same length. Okay, so that's equilateral. Base is the next term. The base is just a what part of the figure, when the figure is turned a certain way, it's sitting on its base. Now, trapezoids have two bases. You don't count their slant heights as bases. This would be a base. I always call the big base base 1 and the little base base 2. Triangles have 3 bases. Right now it's sitting on its base. If you have an isosceles triangle, that means that two sides, these are called your legs right here on an isosceles, and this would be the base, which is really important to note. All right. So that's a base. And the last one is vertices, which is the plural form of a vertex. So this trapezoid has 4 vertices. 1, 2, 3, 4. So just so you have that vocabulary down, we're going to go to the next slide, and we're going to start talking about quadrilaterals and their properties. So we're going to start with the property of a parallelogram. So go ahead and write that down somewhere, maybe on a card or on your notes, and draw a parallelogram. Please label it A, B, C, D. And we're going to talk about some of the important properties of a parallelogram. What we're concerned mostly about right now is that the diagonals of a parallelogram. Diagonals, that would be line AC and our segment AC and segment BD. Those are diagonals. And what you need to know is that diagonals of parallelograms, the diagonals bisect each other. Okay? They bisect. Bi means cut in sections, cut in exactly the same size sections, bisect each other. That's really important to note. So AC bisects DB, and it makes them the same length, D to the center. If I named that E, that would say I could say that DE is congruent to BE. And also the other direction, DB bisects AC. And so I could say that AE is congruent to CE. All right, so that's really important to note that they bisect each other. Now, something else to note is that they do not bisect each other at right angles. These two angles will be congruent, and then your vertical angles will be congruent, but they will not be 90-degree angles. If you need an altitude to the base, you will have to create one. All right, you will have to create one. Something else that I'd like you to note is that you've got it's sitting on its base DC. Its height will connect the two bases of your parallelogram by a right angle, so that's a height. You can also connect it from this vertices to the opposite side, and what you'll see is you'll create a rectangle and 2 triangles, and if I wanted to, I could cut that out and drag it over here, and I would end up having a rectangle. So we would just look at from this point here and around. But anyway, there's a couple more properties of parallelograms that I want to talk about. We need to note that the opposite sides of a parallelogram are congruent. So side AB and side DC are congruent. Same thing is happening with your slant sides. Okay, they are the same. Something else to note is that this angle, the opposite angles will be the same sides. Okay, so we're going to say opposite sides are parallel and congruent. Opposite angles are congruent. Also, the one acute plus one obtuse angle will always equal 180 degrees. So for example, angle D plus angle A, your acute and your obtuse will equal 180. Or angle D, which is acute, and angle C, which is obtuse, or C and B, or B and A, etc. And all parallelograms have angles, they're angle measures. Measure of the angles is 360 degrees in all 4-sided figures. All right. Let's see if there's anything else. Nope. I think most importantly is that we note that the diagonals bisect each other. Okay, so that's the properties of a parallelogram. Moving on to the properties of a rectangle. All the properties of a parallelogram do fit the rectangle, so they have the same properties. All the ones that we listed here work for your rectangles. Things to note that you already know is that all the angles of a rectangle are 180 degrees. And you get bisecting, diagonals bisecting each other, and then opposite your vertical angles are congruent. So all that is true. But the other thing to note that's really important is that the diagonals are congruent. So if we were to label this rectangle ABCD, we could say that segment AC is congruent to segment DB. And we could also state that actually we could go back. All four segments of your diagonal, let's erase that if you made that, all four of these signs, all four of these little portions of your diagonals are congruent. So AE congruent to BE, congruent to CE, congruent to DE. So the segments are all congruent. So the diagonals are congruent, and then their little intersections are congruent. Okay, making all of your triangles isosceles. So this triangle here has two sides that are congruent. Triangle BEC is it's an isosceles triangle. This is an isosceles triangle. They're all isosceles. So it's really important to note this. Diagonals are congruent, and diagonals are congruent, and they bisect each other. Okay. And all the bisected portions are congruent. So that's important to note. The properties of rectangles. Moving on, we get the properties of a rhombi. We call a single rhombi a rhombus. Okay. Now, important things to note about a rhombus. A rhombus is an equilateral, so that means that all sides are congruent. So we'll label it again, A, B, C, D. And then their midpoint where they intersect can be E. All sides of a rhombi are congruent, so that's what those markings mean. And the diagonals, again, the diagonals bisect each other. Okay, they bisect each other. So that means that I'm going to mark AE and CE as congruent and DE and BE as congruent. You'll note that the diagonals are not congruent to each other. But even something else that's really important is that the diagonals are perpendicular. So they create four right triangles. And coming up on Pythagorean theorem, which is dealing with your right triangles, knowing that the diagonals bisect and make four congruent right triangles, okay, is important. Diagonals are perpendicular and create four congruent right triangles. All of the four triangles are exactly the same size. Exactly. Okay? And we will have to use given information to find lengths of diagonals or lengths of sides. So it's really important that you know all of this stuff about a rhombus, so write all that down. We got one more here, two more. We got the properties of a square. On squares, anything that has to do with a rhombus, all the properties of a rhombus fit a square. What's different about squares? You know what? Let's go back to rhombus really quickly. I didn't note, I'm sorry, that the opposite angles of a rhombus are congruent as well. So sorry about that. Angle A and C would be congruent, and D and B would be congruent as well. So opposite angles are congruent. All right, so let's just add that really quick. All right, so when we're going to properties of squares, all the angles are right angles. Again, your diagonals, which are important, diagonals bisect each other. And they are also, the diagonals are perpendicular. And the diagonals are congruent. In this case, the diagonals are the same length, which is different from the rhombus. Okay, your diagonals here, AC is the same length as BD, and that's not the same case in a rhombus. So all of these will be the same length, by the way. We'll put an E there. All of them will be the same length. They intersect at 90 degrees, which is important. Okay, and all four of these triangles, like in the rhombi, all four of the triangles are congruent. All right, so big important stuff again. Gotta know diagonals bisect each other, that they're perpendicular, forming your right angles, which is important for Pythagorean theorem, and that they're equal to each other. And that means that their little halves are equal to each other as well. AE is the same as CE, is the same as BE, is the same as DE. So they're all the same length. So really important stuff on the diagonals there. And we got one more, and that's the trapezoid. All right, first we're going to talk about the isosceles trapezoid. So draw your picture of your isosceles trapezoid. On an isosceles trapezoid, your two slant heights are congruent. That's what the isosceles means, the little legs on the side. This is your base 2, this is your base 1. Again, you've noticed that I've put some diagonals in here. Your diagonals in an isosceles trapezoid, your diagonals are congruent. So if we label it A, B, C, D, and E at the center, the diagonals are congruent. But something that's different here is that the top segments of your diagonals will intersect and give you an isosceles triangle up here at the top. So we would say that AE is congruent to BE, and then on the bottom, those two are congruent. So DE is congruent to CE, and they do not always intersect at 90 degrees. So the opposite angles will be congruent. They're your vertical angles. Okay. All right. And something else that's important about isosceles trapezoids to note is that the base angles here will be congruent. These will be the same. And these ones up here will also be the same. So you have those measurements in there, which is important to note. All right. And these two will add up to 180 degrees, the acute and the obtuse. And these will add up to 180 degrees, angle C and angle B. Okay. So that's the isosceles trapezoid. Sometimes on an isosceles trapezoid, you'll be asked to find a slant height, and you'll be given the height. And the height is the altitude. It's what you do when you find the height is you just connect the tip of the shorter base to the bigger base with a right angle, and that'll give you your height. And so, for example, if I knew that this was 5 and this was 7, and I had to figure out what this length was right here, if I go and do the same thing on both sides, since this is an isosceles trapezoid, this is 2 longer than this, 7 is 2 longer than 5. If it's an isosceles, this would be 1 unit and this would be 1 unit. Okay, and you could use this information to help you find side lengths or help you find the height. So it's important to note the height, where the heights go. Now on other trapezoids, you have your bases as before, base 1 and base 2. In this one here, you have 2 slant heights, so you would have to create your altitude or your height. All right, and you can do that however you want. On this trapezoid here, you have 90-degree angle here, so this could be considered your height, or you could cut it over here and this could be considered your height. So that's something else to note. All right, you'll notice that I talked a lot about diagonals in this video, so make sure you have these properties copied down, because you're going to get a lot of word problems here. They're going to tell you to draw a trapezoid with diagonals, and you're going to have to know what those diagonals do. So make sure you've got all of these little important things that I talked about, diagonals, in the figures and what kind of angles they create. Really important. Okay, so make sure that you guys do that. And that is all I have for you today. Hope you have a great afternoon. You have a quiz tomorrow on all this, so I hope you took good notes. See you later.